Alright, so now that everyone have an account and have logged in, this should be what you see when you log in first time. So here on the right you have the quantum systems and simulators that you can access with this free account. So you can see they have some 14 qubit chip here, where there are 9 algorithms waiting to be run. And then there's a number of 5 qubit devices here. And then they have, at the end here, a simulator, which can handle up to 32 qubits. And currently no one has any jobs waiting to be run there, so we should be good to try out things. So you see here there are basically 2 ways to create programs or circuits here. One is the graphical interface, which is the simpler. We'll take a look at that first. And then you can also write a Python notebook where you compose the circuit with code rather than drag and drop. And this is perhaps more useful later when you do more advanced stuff. But let's see. Then okay, in the right here, the menu, you can find tools like you can see results of previous runs that you have down on the quantum computers here. You can go to the circuit composer, or you can go to make or all the circuits you proposed or notebooks you've made. And there's some documentation. But if we go to the start and we create a circuit with circuit composer, then it looks like this. So here you have a number of single and 2 qubit gates that you can drag and drop to then this setup. So here you have, in this case, 5 qubits, and this here is a classical register where you can register the results of measurements. You can go to a guide here to see sort of exactly how you can do this. You can start making circuits and run them. You can see here on the left, you can do settings, you can change the number of qubits that you have access to here. But we'll stick with 5 for now, because that's what they have on most devices that you have access to. Here you can see sort of the code that actually creates the circuit that you would create by dragging and dropping. This is more what this is in the language called OpenCASM, so this is a standard language for defining quantum circuits. And then here you can see what the output should be. It's not okay. But let's see. So you should try out the first simple circuits. So let's say you want to do just some gates on this single qubit. So they all start in 0. So if we do an X gate, we will flip it to 1. And now, when you've created a circuit like this, you save it. You have to save it before you can run this. You can change the title here. And then you can run it by clicking the button. But you need to get the useful output, as I understand it, you need to do a measurement. So you drag and drop this measurement, it measures in the computational basis, 0 or 1, and puts the result in the classical register. And when you have a circuit like that, you can run it, and then you are given a choice of backends to to run it on. You can write on a simulator, that's sort of the default here, or you can choose one of these other devices that were listed there. So unfortunately here you can't see which ones have a long queue, so you would have to go back to the start to see that. And then you can select here how many times you should run the circuits to gather, if it's some complicated circuit, maybe you need many measurements to gather statistics of the output. And then you run it. And here it says then I have a, okay. It's now sent to the simulator, and then the result will appear. So try out the, we got the result already. So what should the result be? Hopefully.
1-0.
Let's see.
It was too complicated.
Too complicated. Okay, but I think you get the point. So I suggest you try to run these 3 simple circuits, like the H at H, and the decomposition of the swap, decomposition of C naught, and see if they give the right results, provided that you can actually access the results.
So I've just set it up so that you've got the measurement, and then to add the qubit seems good.